This is page 1 of the Unit 3 test, and what I want to do is go over these multiple choice questions to some degree, anyway, show you how I would approach them. So the first problem, researchers studying growth patterns in children collect data on the heights of fathers and sons. So I believe what we have is we have the father's height of fathers, and we have the height of sons. Okay, the correlation between the father's height and the sons of their 16-year-old sons, 16 years, is most likely to be. So what would the correlation most likely be? Well, we know that the height is determined by genetics, and so a taller father is likely to have a son that's also tall. A shorter father is likely to have a son that's not as, or is also short. However, there's certainly, this probably isn't the only factor. There's another factor, and that's the mother's height. So we know there's going to be some variability, okay? So, but it makes sense that as the father is taller, the sons are likely to be taller. So we can kind of rule out -1. And also we could rule out 0. There is going to be some relationship. I don't think it's going to be have a curve, but it's certainly not going to be 0. So we can rule out B. Okay, now somewhat greater than 1. Well, a correlation is never greater than 1, right? R is always greater than -1, greater than or equal to -1, or less than or equal to 1. So we can rule out this one. So the only two that are left is exactly 1. So that would mean it's an exact straight line. And that doesn't make any sense either, because like I said, there's other factors like your environment, how you eat, maybe any childhood diseases that maybe hindered growth or something, and certainly your mother would be a factor. So it's not going to be an exact straight line. So the only one that makes reasonable sense is C. Okay, that's how I would approach that one. Which scatter plot shows a strong association between two variables? Okay, well, this one looks pretty strong. I would say this is not super strong. It might be an association, but not super strong. This one looks pretty strong. And this one definitely looks strong. And then this one would be not strong at all, because these are scatter plots, not residual plots. But then there's another part to this question. Even though the correlation is probably near 0, so there's no linear correlation. Well, this one looks linear to me, so I would rule that out. And this one looks like a negative, but definitely linear, so I would rule that out. So the only one that doesn't have a linear, it's a strong association, but it's not linear, probably going to have a line that goes through like this, is this one. So the answer is C. Okay, correlation between families' weekly income and the amount they spend on restaurant meals is found to be, okay, R is 0.3, which must be true according to the model. Families tend to spend about 30% of their, no, a correlation is not, R is not about percent, so this is wrong. In general, the higher the income, the more the family spends in restaurants. Yet, in general, just a little in general, the line of best fit passes through 30% of the income restaurant data points. No, that's really weird. That's just a weird thing to say. Because it says, you know, I guess if there were 10 points, then it would pass through, exactly through 30% of them. So that's just weird. So it's not this one. Okay, so the most reasonable answer would be B. Okay, so let's keep moving forward. A medical researcher finds that the more overweight a person is, the higher their pulse rate tends to be. Okay, so weight, pulse rate. Okay, I'm just trying to think through this. Tends to be. In fact, the model suggests that 12-pound difference in weight are associated with a difference in pulse rate of 4 beats. So I guess something like this. If you go up 12 pounds, the pulse rate's going to go up 4. Which is true. The correlation between pulse rate and weight is 33. Well, it doesn't really tell us anything about correlation. Just this tells us about the line. If you lose 6 pounds, your pulse rate will slow down 2. Well, yeah, according to this, but this is too strong a language right here. Will. You know, we should say the model expects, but it doesn't mean this is certain. This implies cause and effect, so this would be wrong. A positive residual means a person's pulse rate is higher than the model predicts. So let's see, a residual is E, it's y minus y hat. So positive means y is bigger. So let's see, so y is greater than the model up here. A positive residual means a person's pulse rate is higher. Yes, it's higher. So this would be y hat for this particular x value. And this would be y. So yes. So the answer 3 is correct. So the answer is D. Okay? Number 5. A least squares line of regression has been fitted to a scatter plot. The model's residual plot is shown. Which is true? The model is appropriate. Well, yeah, we see random scatter with no pattern. A. The linear model is poor because some residuals are large. No. That doesn't matter. We're just looking for random scatter. The linear model is poor because the correlation is near 0. Well, we can't even tell what the correlation is from this picture, so that doesn't make any sense. A curved model would be better. No, that doesn't imply. We don't even know for sure. But if the residual plot looked like this, then maybe so. But in this case, it doesn't look like that. All right, so A is the answer. Okay, last one. All but one of these contain a blunder. So a blunder is like a mistake. Okay, the correlation between a football player's weight and the position. So the position you play is not a quantitative variable. That's categorical. So that's not going to work. The correlation between amount of fertilizer used and the yield of beans. Okay, so that's probably going to work because those are 2 quantitative variables. The correlation between a car's length and its fuel efficiency is 0.7. If they would stop there, that might work, but the correlation is not, it has no units. It's a unitless measurement. Remember, R is just, it's just a number between, well, greater than or equal to -1 and less than or equal to 1. So it has no units. So that's not. There is a high correlation. Well, it can't be greater than 1. So that's wrong. The correlation of 0.63 is between gender, which is categorical, and political party. So once again, categorical. So the only one that seems to fit is B. Okay, so that's the first page of multiple choice questions for this test. Good luck.